Hi everyone, just going to walk through the key parts of this week's notes, just nearly all of them, hopefully. I'm going to jump to the table of values. So how do we sketch a graph using a table of values? Well, it's pretty manual. For example, here's an equation x plus y equals 4. It's not even arranged as y equals, which is our normal form. It doesn't have to be, but I know that I prefer to, but I can work out the answers. If x and y have to add to give 4, if x is 0, well, y had better be 4. If x is 1, well, y had better be 3. And if y is 2, x is 2, y had better be 2. So clearly, yeah, I can fill it out that way. I also could have used a bit of algebra and said, alright, so x plus y equals 4. I'd rather do it in a y equals form and just sub the x in. If I want to get rid of the x from the left-hand side, it's only an x that's sitting there, a positive x. I better subtract it away. I don't divide it because it's not timesing anything. I'll subtract x away from both sides, which gets rid of the x. Gives me y equals 4 minus x. Note I could have written here, and I'd be just as right. I could have put in the minus I could have put the minus x to the left and left the plus 4 there. Just note, it really doesn't matter. But those two answers are exactly the same. They're both y equals. One's a 4 and a minus x. The other one's still a 4 and a minus x. They're the same. But anyway, that format might be easier. When x is 0, 4 minus 0 is 4. When x is 1, 4 minus 1 is 3. When x is 2, 4 minus 2 is 2. So either way we do it, okay, then we say, well, where's the point 0, 4? Well, horizontally, x-wise, I don't go anywhere. I don't go left or right, I go 0. Vertically, I go 4. That's the point 0, 4. The point 1, 3 is go to 1 in the x direction, go to 3 in the y direction. The point 2, 2, go to 2 in the x direction, 2 in the y direction. And you can see, really only needed 2 points, but I like to at least use 3 as a bit of a check. Yes, of course, they're all going through a straight line's going through those points. So that's how to sketch anything using a table of values. Person I'd arrange it to y equals, put in some numbers, and then we're home and hosed. What about the intercept method? Now, it doesn't work all the time. If the function doesn't pass through the origin, then the intercept method won't work. Quick explanation, what's the intercept method? If I tell you a curve has a y-intercept, a straight line, we're not doing curves, has a y-intercept of 3 and an x-intercept of minus 1, then it's pretty easy to draw a line through it. Okay, so if I find an x-intercept and a y-intercept, I'll just draw the line through it. What if the line goes through the origin? Its x-intercept is 0 and its y-intercept is 0. It doesn't help me sketch it. So the intercept method only works when I've got a line that's on a slope. It cuts the x-axis and the y-axis. So it doesn't work when it's horizontal or vertical or if it passes through the origin. But it still works in a lot of cases. Long story short, if the line is on a diagonal, we can use it if it doesn't go through the origin. Okay, and let's find out. The x-intercept of a straight line is the x-coordinate where the line cuts the x-axis. In other words, if a line cuts the x-axis, here's x. If a line cuts it, I know the y-intercept there. Let's say the x-intercept is 2, but what's the y-intercept at that point? It's not up, it's not down. The y-intercept, the y-coordinate, it's 0. I know the x is 2, I can see that, but what's the y? Again, not up, not down. The y movement is 0. So x-intercepts happen when y equals 0. It's about to pop up soon too. I'll just say it while I've got a diagram here. This point here, that's a y-intercept. Clearly it's got a y-coordinate of 5, we know that. What's its x-coordinate? It's not left, it didn't go right, it's 0. So if that sketch makes sense, that if it cuts at an x-coordinate, you know what the x-coordinate is. If it cuts in this y-coordinate, so the x goes on the left, the y goes on the right, and the other coordinate must be a 0. So that's why we came up with the x-coordinate, or the x-intercept, is when y equals 0. So we'll do an example in a sec. Also, the y-intercept is when x equals 0. So we can walk up to any equation, not even bother to rearrange it, just chuck in y equals 0, it will spit out an x-intercept. Then go back to the original equation, chuck in an x equals 0, it'll spit out a y-intercept. Example, please. Here's a function. I know I like writing them as y equals, but I'm not even going to bother. I'm just going to go through the steps and say, well, it doesn't matter which one I do first. I'll let x equals 0 to find the y-intercept. If x equals 0, instead of 2 times x, it's 2 times 0. Minus y plus 4 equals 0. What's 2 times 0? 0. What's 0 minus y? Well, the 0 doesn't have to be there. It's exactly the same as minus y. In the same way, what's 0 minus 5? It is minus 5. I don't have to write the 0 there. 0 minus 5 steps is minus 5. Okay, and here I'm saying, well, I want to clearly get my y-intercept, get y equals. The quickest way to do that is, if I've got a minus y here, how do I get rid of minus y? By plus a y. So I'm going to add y to both sides. The minus y cancels the plus y, and end up with 4 equals y. In other words, there is my y-intercept. Okay, I'm going to erase that and just note, I found my y-intercept. y-int equals 4. Now, let's go over here. Now let y equals 0 to find the x-intercept. If y equals 0, I'm going to rewrite this equation. Say 2x minus, instead of y, I'm going to write 0, plus 4 equals 0. Minus 0, well, that doesn't do anything. It's still 2x plus 4 equals 0. Get rid of this 4 by taking 4 away, because my aim is to get the x by itself. So I'm going to get rid of the 4, then I'm going to get rid of the 2. That gives me 2x equals 0 minus 4 is minus 4. How do I get rid of that 2? I don't subtract it, because that 2 is timesing. It's not 2 plus x, it's 2 times x. So I better divide by 2 to do the opposite to times 2. Gives me x equals, well, minus 4 divided by 2 is a minus 2. So I know my x-intercept is minus 2. I know my y-intercept is 4. So my sketch is pretty easy now. A y-intercept of 4, I'll put you about here. Now clearly these sketches are not to scale, but do it roughly. It's just good practice. If that's 4, where would x of minus 2 be? Minus 4 would be there, about there. And then draw the line. Actually, that was one of my best. Okay, now just for nerds' sake, the answer's done. I sketched it using the intercept method. Just note, if I did do this equation and rearrange it into a y equals form, I could add y to get rid of the minus y and add y, would give me 2x plus 4 equals y, which, just to make it more comfortable, is the same as y equals 2x plus 4. And what we're getting to in this lecture is soon going to talk about the y-intercept being, alright, that plus 4 is the y-intercept, you bet it is. And this 2 we're going to refer to as a gradient. And this is a positive gradient of 2. That's what we looked at last week. And it is, because it's a positive and it's a 4 over 2, which is 2. So everything's come up Milhouse. Equation of a straight line. Well, why is there such a big space there? The y-intercept of a straight line, yeah, that's why. We learned about gradients in week 1, so the m part of my equation of a straight line is sorted. But I need to introduce this concept of the y-intercept, or carry on with it, because we just did one. And what is the y-intercept of a straight line? It's purely the y-coordinate of where the line cuts the y-axis. And we call it B. I don't have a good logical reason why it was denoted B. You know, B stands for y-intercept, but it does. So you don't give the coordinates. I don't call that, 0, 3. What's the y-intercept of this line? Just 3. B equals 3. It cuts at 3. So the y-intercept, these bluey grey backed ones are just multiple choice ones I chuck in here. Pause it if you want to nut it out yourself. Put a few trap ones in there, but what's the y-intercept of the following line? Don't complicate it. It's just where the line cuts the y-axis, which is clearly at -1. Okay. So now let's put these two things together. There's a gradient intercept form of an equation of a straight line, which is this. This is our friend. As soon as any question says the word equation, we're going to go, yoink. If you're asking me for an equation, I'm going to use y equals mx plus b. And we'll see what it means, but we know that m is gradient and b is y-intercept now. So if I know the m and the b, I'll just sub them in there. If someone said, what's the equation of a line with a gradient of 3 and a y-intercept of 2, I'd say, gradient of 3, m's a 3. Y-intercept of 2, b's a 2. And I'd say my answer is y equals 3x plus 2. That is the equation of the line with a gradient of 3, I see you there, and a y-intercept of 2. Okay, so let's do an example. Well, so this example here is just saying, well, what's the gradient y-intercept of this line? Since we know y equals mx plus b, and this is written in the correct form, y equals mx plus b, I can see that the m is clearly the 2. The m is always timesing by the x. Now, I don't care whether, like this question could have been written y equals 3 plus 2x. That's the same question. Don't think of m as on the left. It won't always be on the left. But m is always timesing the x. That's m. b is always sitting by itself. It might be a plus, it might be a minus. Same with the m, it might be a plus or it might be a minus. Any number we ever look at owns the sign to its left. If I see a 3 and a minus 2, that means I've got a positive 3 and I've got a minus 2. I could write that as minus 2 plus 3 if I wanted. It's exactly the same thing. Every number owns the sign to its left. And if there's nothing there, we know it's positive. So anyway, gradient here is 2 and the y-intercept is clearly 3. What about the next one? Well, the gradient is whatever the x is being times by. It's a 7 in this case. The y-intercept is the number out by itself. It's a minus 1. These ones are written without any rearranging needed, as in, they're all coming at me y equals. Alright, that's the form we want. What's the m here? If I'm looking at what's this x being multiplied by, there it is. The x has been multiplied by minus 2/7. If you think about it in terms of fractions, if I said, I'll just write it here, what's minus 2/7 times x? I'd put the x over 1, wouldn't I? And when I multiply fractions, I just multiply the tops, which would give me minus 2x. I'd multiply the bottoms, which would give me 7. That's exactly right. That x has been multiplied by minus 2/7. What's the gradient? Y-intercept? Plus 4. Because it's sitting there. The last one on this page, what's that x been multiplied by? It's not 2. That'll say 2x. Hope you can see, actually, it's not been multiplied by 2, it's been multiplied by a half. Note that any time you've got an x by itself, you can always put a 1 there. And that makes it clearer to me to see that my gradient is a half. Is it true that x times a half equals x on 2? Well, definitely if I consider x as an x on 1. X times 1 is x, 1 times 2 is 2. Yeah, it's exactly the same thing. So if a question said y equals x on 2 like this one does, or if it said y equals a half x, same thing. X on 2 and a half x are the same thing. And the y-intercept is just minus 3 on 2. Might look a bit fancier than the others, but who cares? It's just minus 1 and a half. Doesn't matter which way we write it. There's the y-intercept. Okay, so now sometimes forms of equations aren't in the form y equals, but we can convert them to that way. So here's an example, 2x plus y equals 5, and we want to know the gradient and y-intercept. I'm not going to pretend to know what the gradient or y-intercept is until I look at it in the y equals mx plus b form. So y equals mx plus b is what I want it to look like. What does it look like now? This. I want y equals by itself. It's a positive y. The only thing I want to get rid of is the 2x. How do I get rid of a 2x that's just sitting there? I'll subtract it. It's not timesing anything or dividing, it's just sitting there. So I'll subtract 2x away from both sides, which will leave me. Now I could write 5 minus 2x, but I'm going to put the minus 2x to the left and the plus 5 to the right. Same answer. I just like to make it look in the same order as that one, even though it really doesn't matter. But we can see our answer now. M is what x is being multiplied by, which is a minus 2, and b is the number by itself, which is plus 5. So if we want to know the gradient y-intercept of any equation, just rearrange it to y equals, and you'll be able to spot it. Find the gradient y-intercept of this one. Well, it's the same question, it's just a different equation to play with. X plus 2y minus 8 equals 0. That's the general form of the equation, which in this course we don't really go on about, if at all. But in textbooks you might hear about the general form. Well, this is the general form. It's got the x's, the y's, and a number equals 0. But we don't really care what its name is. The form that we care about is the gradient intercept form. Why do we care about it? Because y equals mx plus b shows us the gradient and the intercept. Hence we call that the gradient intercept form. Creative. Now here I want the y equals, I want to convert it to gradient intercept form. So there's a few things I want to get rid of. I don't want the x, I don't want the 2, and I don't want the -8. The easiest things to move first are the things that are just added or subtracted from it. Like, let's just get rid of this x. How do I get rid of an x? I'll minus it. As long as I do it to both sides, we're all good. So that's been subtracted from the left, and it's now 0 minus x is minus x. Now let's get rid of the -8 by plussing 8. Sorry about I'm not that neat. I've got the screen on a vertical so the video works, which is probably not a positive thing, seeing my head. -8 plus 8, I've cancelled that out. I've only got a 2y on the left now, and on the right I've got -x plus 8. The last thing to do is get rid of that 2. At the moment it's timesing, so I'd better divide by 2 to do the opposite. Divide by 2. Y equals -x divide by 2 plus 8 divide by 2. They both cop it, they both get halved. I wanted to halve the entire right hand side. That's what I've done. Minus x on 2, I could write minus half x if I wanted. No, we're confident. Plus 8 on 2, let's just call it 4. So there we go. You can see your gradient is a minus a half, because again I can put a 1 in front of the x and it clearly shows me a minus half is multiplied by the x, and the y-intercept is just a 4. Okay, I couldn't see that in the initial form. I had to go into the y equals form, and then I could. Okay, the horizontal line. We've been talking about lines on a diagonal. M can equal 0. Lines can be flat. Flat lines. Wow, that's worst flat line ever. That's about the same. See this line here? That's flat. That grid line is m equals 0. Okay, so let's just look at this one. It's asking about, for example, the line with a gradient of 0 and a y-intercept equals 3. Well, if it's got a y-intercept of 3 and it's got a gradient of 0, it must be this flat line along here. Yeah, and that's what it is. I could also have done it manually and said, well, y equals mx plus b. If the gradient is 0, it's 0 times x. If the y-intercept is 3, well, that's 3. What's 0 times x? 0. Y equals 3 is all I'm left with, and sure enough, that is the name of this function. So y equals 3 is a horizontal line that passes through y equals 3. It can be confusing at times because I think y-axis, I think vertical. But the y equals line looks horizontal. But it has to be, because if I sit on this line, there I'm at 1, 3. There I'm at 2, 3. There I'm at minus 3, 3. X can be anything. There's an infinite number of values that x could be. I could sit anywhere on that line and x is a unique value. But y is always equal to 3. So the easiest way to know is if a line is horizontal and it just passes through y equals 3, that's its name. And the next page showing vertical lines, the same logic applies. This one talks about, well, I can't sub in, we say the gradient is undefined, so I can't just sub infinity or undefined in for the gradient. But we know that, well, if y equals 3 was a horizontal line passing through y equals 3, I hope the logic exists that, well, x equals 2 would be the vertical line passing through x equals 2. Anywhere I sit on that line, the y might change, but the x is always 2, despite what I wrote there. Great. Finding the equation of a line given a point and the gradient. Okay, so here's a point, here's a gradient. So initially I'm thinking m equals 3, gotcha. I know the point is an x coordinate and a y coordinate, but ideally, if I'm going to find, as soon as it said the word equation, I said before, this jumps up. You're asking me to complete y equals mx plus b. In other words, I want an m and I want a b. I've got an m, I can fill that bit in, but I'm not told what the y-intercept is. It goes through the point 1, 4, let's just look at where that is. Here's a point 1, 4. Well, 4's not the y-intercept, is it? It's got a gradient of 3 at some steep gradient, something like that. I don't know what the y-intercept is, but I could draw up an accurate graph and graph it and find it that way, but we don't need to. we use this. We've got all the information we need. We know that the point 1, 4 makes this equation work because this point sits on the line. What I'm saying is x equals 1 and y equals 4 must satisfy this equation. So just chuck them into it. Replace that y with a 4. Replace the x with a 1. I've got an equation with the only unknown as b. Let's solve it. 3 times 1 is 3. How do I get rid of that 3? I'll take it away. If I take 3 away from both sides, 4 minus 3 is 1 equals b. 1 equals b, b equals 1. We've got it. My sketch actually wasn't too bad. That looks pretty good. The y-intercept is 1. But overall I've got m equals 3 and y equals 1. That means I can finish my equation. I knew y equals 3x plus b. It's y equals 3x plus 1. There's my m. There's my b. And there's my answer. From the equation of a line passing through, okay, it's the same question. I've got a point and a gradient. Alright, gradient is minus a half, so m equals minus a half. So my equation already, instead of just being y equals mx plus b, I can replace the m and say y equals minus a half x plus b. But again, I've got an x and a y that's going to make it work. Careful you get them around the right way. It's always alphabetical order, as in x comes before y. Replace the y with a 3. Replace the x with a 1. And remember, there's always a times in between an m and an x. Any two letters in algebra hard up against each other. Yes, it's the times between them. A number and a letter. Yes, it's the times between them. What's minus a half times 1? Well, it's still minus a half. How do I get rid of a minus a half? Oh, plus a half. So 3 and a half equals b. I've got a b, I've got an m. My final equation will be y equals minus a half x plus, what was it, 3 and a half. Yep, that's my answer. Now, are there other forms of that answer? Yeah, and it doesn't matter which way you go. I could have called it minus x on 2. We discussed before, that's the same thing. I could call it plus 3.5. I could have called that y-intercept 7 on 2 if I wanted. That's just the difference between a mixed fraction and improper fraction. It makes no difference. These are all correct answer. So I've got a few extra examples here. Find the equation of the following linear functions. Well, this one, I'm not given the gradient and a point. But am I? I'm not given the gradient, but I can work it out pretty quickly. First thing I'd like to do is say, is the gradient plus or minus? If I'm not good at drawing. See? Yeah, that's a person. Stop it. If that person walks along it from left to right, they're going downhill. It's a negative gradient. It's not a rise over run. It's a fall over the run. It's a minus. Then I want to say, well, what's the rise? Well, the fall in this case. This side length is 4, and this side length is 2. So it's a minus 4 over 2. Another way of looking at it, in walking from this y-intercept to this x-intercept, my rise was a minus 4, and my run was a 2. So my overall gradient, minus 4 divided by 2, is a minus 2. Now, were we given a point? Well, we're given 2 points. That's the point, 0, 4, because we know the y-intercept goes on the right. That's the point, 2, 0, because we know that the x coordinate goes on the left. But there's something staring at us in the face. What's the y-intercept of this line? 4. We can see it. It's actually marked on the picture. My gradient's minus 2. My y-intercept is 4. We're done here. Y equals mx, which is minus 2x, plus 4. That's the equation of this line. Gradient of minus 2, y-intercept of 4. Another one. We're given the y-intercept again. Great. I'm going to write that down first this time. My y-intercept is the number 1. My gradient is, it's a positive. My vertical is a 1 over a horizontal of 2. Now, just because that's the number 1 and that's the number minus 2 doesn't mean I put 1 over minus 2, hence the gradient's negative. It's not, is it? It's a positive gradient. The gradient doesn't depend on, its sign doesn't depend on what the sign is of the numbers it goes through. its gradient depends on when I walk left to right, it'll go up or down. This is an upward slope, this is a positive gradient, 1 on 2. My final answer is y equals mx, which is a half x, plus b, which is plus 1. It's pretty quick. Hopefully not too quick. Put me in slow-mo if so. Here's another extra pause moment if you want to work this one out for yourself. Pause finished. What's the y-intercept? 1. Yes, yes, yes. Go away. What's the gradient? Plus or minus? Definitely minus. Go away. It's not going to be a plus 2 gradient. So what have I come down to? My gradient's either minus 2 or minus a half. Well, yes, it's minus. We've determined that. The vertical side is 1. The horizontal run is a half. So it's a minus 1 drop over a half. How many halves are in 1? 2. It's a gradient minus 2. Yeah, it's steep. It's not shallow. It's a gradient. It's negative. It's minus 2. B. Good. Another one here. I think this one's put before the introduction of the question. I think I've got the order wrong here. It doesn't matter. I think a heading's coming up. How do you find the equation of a line passing through 2 points? Well, let's do it. Here's 2 points. There's a little triangle. Now, I could go for the formula here. If I said, I hate this, I don't want to do it graphically, I'll do that in a second. Firstly, truth is I do want to do it graphically. That's an x of 1 and a y of 2. That point is an x of 4 and a y of 5. So my vertical side goes from 2 to 5, that's 3. My horizontal side goes from 1 to 4, that's 3. My gradient is definitely a positive, 3 over 3. Which, when it's at home, gets called 1, m equals 1. If I didn't like that, I would have gone for the point gradient formula. I might have called uxy and called uxy, and then called one of the points 1 and 1, and one of the points 2 and 2. Doesn't matter which ones I picked, as long as one of the points got both copped 1s and the other point both got 2s. Then I'll say my y-intercept is y-intercept, hello David. Then I'll say my gradient is y2 minus y1 over x2 minus x1. Remember, it's always the y's on top because it's a vertical rise over horizontal run. No x's on top, it's the y's. The y2 is 5 minus y1 of 2. The x2 is 4 minus x1 of 1. It's a 3 on 3 deja vu equals 1. So whatever your preferred method was there, we got a gradient of 1. Now, this time, unfortunately, it didn't show us the y-intercept. Maybe it's 1, but I'm not going to guess it. We're going to treat it like the one prior, where we had the gradient and a point. I've actually got 2 points. It doesn't matter which point I pick. I'm going to pick on 1, 2, that'll do. And I know that's an x and that's a y that makes this equation work. What equation? Y equals mx plus b. But the m is a 1, because we already worked that out. The only thing I don't know is the b, and we'll do what we did before, sub in these values. When y is a 2, that's 1 times x is now 1 times 1, because x is 1. 1 times 1 is 1. How do I get rid of that 1? I'll take it away. B equals 1. I was right. The y-intercept of this thing is 1. But if I've got m equals 1 and b equals 1, all I've got to do is write the final equation. I could write y equals 1x plus 1. There's nothing wrong with that answer. But note, I don't have to write a 1 next to an x. Y equals x plus 1 is just as good an answer. Okay, another example. Well, it's the same diff. I'm going to go a little bit faster on it. I'll just do the sketch here, I think. This point is x of minus 2, y of 0. This point is x of 6 and y of minus 4. I like to write them in. My gradient is definitely a negative. The vertical side goes from minus 4 to 0, so that's a 4. The horizontal side goes from minus 2 to 6. Well, that's 8 steps getting me from minus 2 to 6. So my gradient is minus a half. Now I can't see my y-intercept, so I'm going to go ahead and sub it into y equals mx plus b. The m is minus a half. So there's my equation again. Let's pick on a point. I don't know. I'll choose that one. Subbing in noughts is easy. If I'm going to pick on the point minus 2 comma naught, that's an x and that's a y. Y is a naught equals minus a half times an x of minus 2 plus b, which is 0, equals minus a half times minus 2. Well, it's got to be plus now, and a half of 2 is 1. How do I get rid of that 1? I'll take it away. So minus 1 equals b, solved. M equals minus a half. Y intercept equals minus 1. So my final equation is y equals minus a half x minus 1. There's the heading for what we just did. Okay, get with the times, come on. Find the equation of this line. Okay, this one I think is already written out in the notes, and I'm sure we do it both ways. We say, well, that's the point 1, 3. That's the point 4, 9. So my vertical side is 9 minus 3 is 6. My horizontal side is 4 minus 1 is 3. I've got a plus gradient, and it's vertical 6 on horizontal of 3. I've got a gradient of 2, or I could have used the formula. The y-intercept, I don't know, but I know that y equals mx plus b, and I know the m is 2. The point I can use doesn't matter, but 1, 3 will do me. I'll do an x equals 1 and a y equals 3. So replace the y with a 3, replace the x with a 1. 2 times 1 is 2. Take 2 away from both sides to leave the b by itself, leaves me with 1 equals b. That's been a popular answer, I think. So m equals 2, 1 equals b, or b equals 1. So my final equation is just replace that b with a 1. Y equals 2x plus 1. Please let that be it. Good. Now I've stuck these in. These are extras. These are still worthwhile doing. The point of putting these in is to get away from table of values. There's times table of values has its uses, and sometimes, like this, it goes to the origin, this one. Where's its y-intercept? Well, it doesn't seem to have any. No, it doesn't. So if I think about this in the form of y equals mx plus b, what's b? Well, it's a naught, because there's nothing there. So if it goes to the origin, the intercept method won't work. But we'll get there in a second, as in, how do I do this without the table of values? Well, let's just play with the table of values. All it says is that y equals 2 times x. If x is minus 2, 2 of them is a minus 4. If x is minus 1, 2 of them is a minus 2. 2 noughts is naught, 2 ones is 2, and 2 twos is 4. What are those points? Well, minus 2, minus 4 is down here. Minus 1, minus 2 is there. Naught, naught, 1, 2, and 2, 4. That's me just doing the x and then doing the y. Alright, that's a nice way to sketch y equals 2x. As you can see, y-intercept of naught and gradient of 2. How do I know it's got a gradient of 2? For every 1 it goes across, it goes up 2. For every 1 it goes across, it goes up 2. Beautiful. What about y equals minus 2x? Same thing, but a minus in the front. Well, I'm going to get the same answers as the previous page, but they're going to change sign because of the negative. Minus 2, or this minus 2 times this minus 2 becomes plus 4. This minus 2 times an x of minus 1 becomes a plus 2. Minus 2 times naught stays naught. Minus 2 times 1 is a minus 2. Minus 2 times 2 is a minus 4. So an x of minus 2 and a y of 4, whoop, it's upside down to the last answers. An x of minus 1 and a y of 2. An x of naught and a y of naught. An x of 1 and a y of minus 2. An x of 2 and a y is minus 4. You can see the gradient of minus 2 happening. For every 1 I've gone across, I've gone down 2. 1 across, down 2. 1 across, down 2. 1 across, down 2. The very definition of a negative gradient. A negative 2 gradients. And if you're looking at that saying, well, how did you know about the 1? What's the gradient of that line? It's minus 2. But I can also say the gradient is minus 2 over 1. Because every single whole number can be expressed over 1. And all I care is that's telling me what to do horizontally. That's telling me what to do vertically. So a minus 2 over 1 says if you're going to go 1 horizontally, you'll go down 2. 1 horizontally, down 2. And so on. Sketch y equals x. Well, that's a pretty easy calc. Every y is equal to every x. If x is minus 2, y is minus 2. And so on. If x is 2, y is 2. Where do I plot them? Minus 2, x goes with minus 2y. Minus 1 goes with minus 1. Naught with naught, 1 with 1, and 2 with 2. That's a nice 45-degree line right through the middle. What's its gradient? Well, I can put a 1 in front of an x, I can put it over 1 as well if I want. I can think my gradient's 1, or if it helps, I can think my gradient's 1 over 1. It's positive, so it means for every 1 you go across, go up 1. 1 across, go up 1. 1 across, go up 1. Yep, that's myself. That's a gradient of 1. Y equals a half x. Well, what's a half of minus 2? Minus 1. What's a half of minus 1? Minus a half. What's a half of naught? Naught. What's a half times 1 is a half, and a half times 2 is 1. So it's got a positive. Let's look. Minus 2 goes with minus 1. Minus 1 goes with minus a half. Naught with naught. 1 with a half, and 2 with 1. So it's doing that. So it's shallower. Its gradient is a half, which means 1 vertical for every 2 horizontal. Here's my 2 horizontal. Here's my 1 vertical. Here's my 2 horizontal. Here's my 1 vertical. Y equals 2x plus 1. Well, let's sub it in again. 2 times minus 2 is minus 4, but plus 1 brings us to minus 3. 2 minus 1 is minus 2, plus 1 is minus 1. 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, plus 1 is 3. And 2 times 2 is 4, plus 1 is 5. Let's plot them. Minus 2 with minus 3. Minus 1 with minus 1. 0 horizontally with 1 vertically. 1 with 3. And 2 with 5. Bit off the scale. And that's what we're getting. And you can see the gradient is 2, which means 2 over 1. For every 1 I go across, up 2. 1 across, up 2. 1 across, up 2. Hopefully you're seeing, yeah, we're going to get rid of these table of values soon. Hopefully this is the last one. Minus a half times a minus 2 is a plus 1. Oop, better not ignore that. Minus a half times minus 2 is plus 1, but then plus 2 is 3. Minus a half times minus 1 is a half. Plus 2 is 2.5. Minus a half times 0 is 0. Plus 2 is 2. You can see the patterns on these. It keeps losing a half, doesn't it? It goes 3, 2.5, 2, 1.5, 1. Why does it keep losing a half? Because that's what the gradient is. Minus a half means every step I go across to the right, I lose a half. Yep, that's what's happening. Minus 2, 3, yoink. Minus 1, 2.5. 0, 2. 1, 1.5, and 2, 1. There's the line, and it's got a gradient of minus a half. I can also think of it like that, that for every 2 I go horizontally, I went down 1. 2 horizontally, down 1. 2 horizontally, down 1. A gradient of minus a half. Oh, more. Y equals x plus 2. I went overboard. I hope you're enjoying the video, or safely fast forwarding through this. When y equals x plus 2, well, let's do it without the table of values because, one, it's not there, and I think if I'd copied the text over, that's what I wrote in the exercises. Well, what can I plot straight on there? That. The y-intercept is clear. The y-intercept is 2. Okay. What's the gradient? Well, what's that x being times by? Number 1. 1 over 1 if you want. How do I do a gradient of 1 over 1? 1 horizontal, 1 vertical. There's my next point. 1 horizontal, 1 vertical. There's my next point. Have I got a pretty... There we go. Thank you. Alright. So plotted. I didn't have to do the table of values. All I need is a y-intercept starting point. Yoink. And then do what the gradient says. Let's do another one. Okay. What's the y-intercept? Plus 1. I've got myself a point right there. What's the gradient? Minus x. So that means what's that x being multiplied by? Again, any solitary x cops a 1. Any whole number can be over 1. So it says minus 1 over 1. It says for every 1 I move horizontally, go minus 1 vertically. For every 1 I move horizontally, go down 1. 1 horizontally, down 1. 1 horizontally, down 1. There it is. Yep, y-intercept of 1, gradient minus 1. Another one. Y-intercept minus 2. Done. Gradient is minus 2. I put over 1, which means for every horizontal step of 1, go down by 2. For every horizontal step of 1, go down by 2. I've ran out of space, but we can see the pattern. I can just go backwards on it. Up 2 and across 1, up 2 and across 1, up 2 and across 1. Once I see the pattern, it's like the move of a knight in chess. and I've got it sketched, graphed even. Y equals 3x. It might seem off putting it first, but what's the y-intercept? There's no numbers there out by itself, which means I can write plus naught if I want. The y-intercept is naught. How do I know if a line passes through the origin? It's got a y-intercept of naught. There's nothing written out here. And what does a gradient of 3 look like? Again, I put any whole number over 1. For every 1 I move horizontally, I move 1, 2, 3 vertically. 1 horizontally with 1, 2, 3, I've run out of room again. But just go backwards on the pattern. 1, 2, 3 down, 1 across. Yep. That's y equals 3x. Gradient of 3 through the origin. Y equals minus 4x. Well, it's got a y-intercept of naught again, so just go for it there. Y-intercept of naught. A gradient of minus 4, put it over 1. That means for every 1 I go across, go down 4. There's my next point. Let's just look at that backwards. So it'll be up there. That's a very steep one. To the origin, gradient minus 4. Another one, what's the y-intercept? Plus 3. Right there. The gradient is 1 on 2. I don't have to write it over 1 this time. It's already written as a fraction. Vertically 1, horizontally 2. And it's positive. So it says when I move horizontally by 2, I move up vertically 1. This is another one, like moving like a knight, that I've run out of space. It would be up here. But okay, 1, 2, 1, 2, 1, 2. I can still sketch it in there. So hopefully you can see, just from looking at this equation form, if it's in the y equals format, I can graph it quite quickly, because I can see the gradient and the intercept. Y-intercept of 1, gradient of 3 on 2, which means for every 2 horizontal, 1, 2, I move vertically 1, 2, 3. Let's backtrack on that. 3 down, 2 across. 3 down, 2 across. 3 down, 2 across. Oof, I've run out. Where's my pretty line? Thank you. I think it's happening. Oh God, how many examples, David? Minus 1. Minus 1. Minus 2/3, horizontal, vertical. For every 3 I go across, 1, 2, 3, I go down 2. Not up 2, it's a minus. Down 2. There it is, 3 across, down 2. Let's reverse that. 2 up, 3 across, 2 up, 3 across. Yep. Made it. Sorry, dying for a drink. Water. It's still daytime at uni, though it is Friday. Okay, enjoy. Bye.